Okay, for people joining this live stream, we're in the late stages of the documentation for what's going into version 12 for synthetic geometry. I do want to raise the issue of the coloring of, let's see, if we go to...
we met already earlier today, and we will make some adjustments.
What do you think you're going to do for that?
A little bit smaller circles, a little bit smaller font, a small change in the blue to a little bit more gray. Modulo Jeremy, which you stole from us in the last meeting.
Okay. Do you have a mock-up you could show me?
No.
Okay. All right. I just think the main problem is, ultimately we want to do cartographic style labeling where we put those things where they won't interfere with anything else. But the issue is right now, these are beautiful, but rather, obstructive.
Right. Michael actually implemented the smaller point and font sizes locally already, although I haven't changed the blueness since I'm colorblind.
Another point that I asked yesterday evening is, do we consider what we now call diagrams in geometry to be more like plots, meaning that the font size of a label is absolute, or do we consider them more like a molecule where the font size is relative?
I don't know. What do you think?
I think the argument for both sides.
Well, I was thinking of some compromise position where they get bigger up to some point.
Yeah, we discussed this. We do not really have decent technology to realize this.
Okay.
Absent that, I think we have to do absolute size, because
I agree.
When the points are kind of mushed together a little bit, you need to be able to stretch out the picture without the points getting bigger too.
The problem is, of course, a little bit amplified in the documentation, because in documentation we typically use size for graphics that's a little bit smaller than the default in a notebook.
Right. Are you colorblind beyond red-green? Like this blue isn't visible?
Well, it's not like it's invisible, but
but you don't think you have the same impression that other people have of it?
Right. Blue and purple kind of mix together for me.
Makes sense.
Yeah.
Interesting. Boy, how do we do in general with our coloring, given your colorblindness? Is the coloring, do we mess it up completely? We have thought about that issue.
What do you, it's
like for syntax coloring and things like that.
Usually, most of the syntax coloring I'm okay with. There are a few cases where deeper down, sometimes it does get a little confusing for me. But like the kind of the top level stuff, if it's a scoping construct, I can tell those apart from.
I'm not sure anybody else is any less confused. Okay, all right, let's continue. I do like the colorfulness of this blue, so don't let's have the whole thing sort of gray into mud, so to speak.
There is one other point which wasn't fully implemented yet. The current emphasizes color we use for the conjectures is the blue, but Jeremy wanted the orange, which we haven't implemented yet.
Locally, I just changed it to orange. It looks good. I could, as far as I know about what orange looks like.
That's funny. That's a funny situation. Okay. Okay. All right, let's keep going here. Okay, so let's start off with triangle center, which I hope and believe will be fairly straightforward.
Up to center 800, it's easy. The other ones are more esoteric.
Up to what?
Joking there, because there are 15,000 centers that people use.
Yeah. Just think how many it would be for pentagons.
Right.
Why aren't there many centers for squares? because it's totally obvious what the center. I mean, for quadrilaterals, there must be many centers as well. Does nobody care about
think
those?
so.
I think a lot of the triangle centers are I think it kind of has to do with 3 points determining a circle. I think for quadrilaterals, once you add points, I think the existence of these centers becomes much more difficult.
I see. Following center types can be used. Okay. Wait a minute. You should list. Don't you want to list these? So the case where the thing has a point.
In all of those cases, they're given as a list up above.
No, I realize that. I'm asking whether that's the right thing. Well, this one here, Sumedian endpoint.
Yes.
Oh, I see. Sumedian point. Yeah.
I think there's no ambiguity.
No, there's no ambiguity. It's a question of whether it's clear what's going on. I mean, because people, what we could do is we could list the ones that are independent of any point first in one table, and then go on and list the ones that require a point. Or is that a waste of time?
I don't necessarily think that's a bad idea, especially for triangle center, in the sense that the ones that don't require a point are kind of more of a center than the ones that do require a point.
Okay. All right. Okay. The following center types. The following basic center types can be used. Okay, so here then we've got Centroid. Yeah, this is a nice list. Circumcenter. I don't know what an Exeter point is.
We don't have it. We're not gonna probably have it anytime soon.
Yeah, I mean, these are all centers that I've heard of. Well, except the Sumedian, which we talked about some times ago, which I hadn't heard of, but okay. The following center types.
Do we want to differentiate between the center types whose additional argument is one of the points of the triangles, and the center types whose additional argument is any point in general? Of course,
which ones? No, let's do the ones. Well, these are all vertex P, right?
CV and endpoint takes both a center point and a vertex P.
Right, and
okay, fine. Well, let's treat that one. So, yeah, what's the other one?
Actually, there might not be another one. Let me look at this. So CV and endpoint.
And on a vertex, depending on specifying a vertex.
Just CV and endpoint's the only one that can have another point in general. Doesn't have to be a vertex of the triangle.
I have an utterly irrelevant question from the live stream, but I'll answer it. The answer is we're hoping so. It's a question of high DPI support on Windows and 12.0. We're hoping so. Okay. Following center types depend on specifying a vertex. And then we're going to say, let's give the table, and then we'll say, well, let's see. The following center types depend on specifying, and by default, taking the point P2 in the specification of the triangle. Okay. Okay, now here's my idea. Okay, so first of all, let's clean it down to that list. Does that one always have to have a center, the CVN endpoint?
No, I think by default it takes the either Centroid or Ortho Center. Centroid, okay.
Oops. Okay, now what I'm going to do here is, okay, here we go. Add row, type, comma, P. Use vertex P. Now, what can P be? What use? What is P? Is P an index or is P?
No, it's a point.
I
One
think
of the vertices.
Right.
No, but what is it when it's a literal triangle center? You get what I'm asking?
So do you want to ask?
When it's not a symbolic triangle center?
Then you give an explicit point.
You mean as a point of 7.2?
Right.
Okay.
We could have it work for indices, and in fact, Dan may already have that implemented, but think about how to document that.
I totally forget whether I implemented it for that one.
Okay, well, hold on. Let's. So we'll just say at the vertex, endpoint of the CVM bisecting the angle at the vertex. And then we remove that. Okay. Is this really the best thing to call it foot as opposed to altitude foot?
In the literature, they use foot.
Okay. Opposite the vertex. Why opposite from the vertex? Okay. Okay, this is what I suggest. Okay, and then we have to say, then we say, okay, Sivian endpoint.
Right. I think Ian has a paragraph on that too below.
I see it. Oh gosh, you've got a way of doing it for all of them? That's super confusing. Is that what you want for this here? Why not do it for every one of them? If you're going to do it for the CVN endpoint.
It does work for all of them. I mean,
Okay.
All works for each of them.
Yeah, I understand. So now we want to say type, comma, all. Give a list of results for all vertices of the triangle. Is that right?
That is correct.
Okay, CV an endpoint of
Instead of use point P, I think it should be use vertex P. 'Cause
okay.
It can't just be any
Yeah.
point.
Okay, but then in that case, can it be an index, or does it have to be in the form?
I forget whether I allow indices. Let me check real quick.
P can be coordinates x, y, point x, y, the index I for, okay, wait a minute, can be a symbolic point specification in a geometric scene. Or can be the explicit vertex in the form xy, point xy, or index I of the vertex. Is that right?
Yeah, it does look like I'm supporting index. I'm not sure if I'm currently supporting point, but I can make that happen pretty easily.
Okay. 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 Type, comma P gives the through the vertex P and the center of the specified type.
It doesn't have to be a type. It can also be an actual point, like 2,3.
Okay. The center can be given as a center type or by explicit or as an or as a point specification. Is that right?
That is correct.
Okay. All right.
He's on the invite list.
Let's go. So let's mute, please. What is that? Oh, okay.
Okay, the pop-up.
Wait a minute. Okay.
It's not always equivalent.
When is it equivalent?
Triangle construct takes more types than triangle center does, which is why
I don't think we should put it in here. I don't think we should put it here. It's not really relevant. Okay. Oh, this is just unbelievably way too complicated. Come on. Just say, find the center of a triangle. Find the in-center of a triangle. I mean, forget all this. What are you doing here? I'm sorry. Look, this should start off just find the in-center of a triangle and just do it,
So we're not-
right? And preferably do one which has nice square roots and all kinds of things like that. You know, I don't know whether this is, just do the thing like
You can
this.
also use
But this is kind of what the first two lines do.
you
I
can
know, but you shouldn't define variables or anything like that. You really, really shouldn't. And you shouldn't ever do this never do this. Never do
No, that's not true, Stephen. Like, you want to prove that it's really the case, and then you don't want to repeat the triangle. That's all.
I know that. But so okay, fine. But first just show with people believing you that it produces all these fancy square roots and things.
Right. Ian, did you do any examples that use abstract input?
You mean like geometric scene examples?
No. I mean
A,
the
B,
coordinates.
C.
No, I didn't.
The abstract coordinates.
You can add some like that.
Yeah.
Yeah, I mean, let's say in center. There we go. But I mean, preferably one which has square roots here, and then we
Well,
can
you
put
can
one.
replace the number coordinates with A1, A2.
Yeah, I understand.
A2.
Right. Well, this is good enough. This is a
Hmm.
fine result. Okay. I'm not okay. I'm not redoing all these examples. I'm just giving you a little indication there. That's beautiful, though, that works.
Very
Okay.
general new feature.
Let's keep going. I think it's really weird that region centroid is called region centroid and not just centroid. Is there a good reason for that?
That's a Charles question.
That's a question for
Let's ask Charles that question.
He is here.
Oh, is Charles here?
Can you hear me?
You're real quiet, Charles.
I'm here. Can you hear me?
Yes, we're asking why is it called region centroid rather than just centroid?
Because we didn't.
We can't hear you. You're breaking up. Say it again.
I say we believe that centroid was too general.
Why? What else could it mean? I'm sorry, you're breaking up. If you could call in some way where you're not going to break up, that would be much better.
Okay, I will try.
Okay, let's keep going here. Oh boy.
I think it's going to be tricky to give this the same treatment we just did triangle center.
Whew. This is a big, complicated mess.
I don't think it's a mess. I think it's actually reasonably structured.
It is reasonably structured, yeah.
It's big, yes.
I would have thought triangle center and triangle measurement. Why isn't triangle center first here?
Obviously, the function that operates on triangles first needs something to operate on.
All right, okay, whatever. All right, well, we'll leave this then. Okay, this is another one of these red things getting left behind in the 64-bit front end here.
No, I think there was a genuine typo.
No, but there isn't any more.
Oh, right. No, it's good.
Okay, all right. Let's go to triangle measurement then.
Are we going to split this into the ones that depend on a vertex and those that don't?
Maybe not. I mean, does it have a default?
Yeah,
Some
the
of these
defaults-
defaults are pretty stupid here. I mean, this is pretty, those defaults seem to be less interesting.
The defaults are the second vertex.
Yeah, I can see it.
Did that for consistency with planar angle.
What is a semi-perimeter?
It's half the perimeter. Apparently, it's an important thing.
Well, we're being a bit lazy here, but I think we don't need to split these because I'm not sure it's very useful to split them.
Right. And all of these P's have to be vertices of the triangle.
Look, there's an argument we should try and split these, but let's get more experience with how this stuff works before we mess around with that.
Yeah.
I would like to see us like encode Euclid or something in all of these things. Okay, let's go to find geometric conjectures since we're already running out of time. Okay, this somewhat horrifying creature. I mean, this is what you spent lots of effort on, right? Is that true or is that not true? Or is this somehow
Not as much as in the scene finding.
Yeah,
but
the scene jar is a bajillion times more code than this.
But this one is more than the triangle center.
Right.
Okay, what else should it point to? Geometric scene, random instance, reduce. What else?
What about sequence finding?
No. By that point, we'd have it point to image identify.
No, like you would never use image identify to make a mathematical conjecture, but you would very well use some of the sequence stuff to find mathematical conjectures.
Well, fair enough. All right.
I'm just.
What's that geometric assertion?
Oh yeah, it should look. That's more relevant than this. It should probably. Is that the right order? Or should it be? I mean, I think random instance is kind of like the very first thing.
I would say until you suggested that the conjecture code operates directly on the scene.
Right, but the scene that the type of scene it needs to operate on can only really come through
I understand.
random instance. Actually,
Okay.
Going back to lines of code, geometric scene actually, I think, technically has the most lines of code by far. Then random instance, then find geometric.
Okay. Lens that might hold for it's a geometric scene with explicit.
Not necessarily.
Okay.
If it's not explicit, then it will find explicit instances to get conjectures for.
It's not the recommended way of doing things, but it'll work.
Which that's
Of the form pat or the match pat.
the match pat.
But the form is typically defined through a matching.
Well, then that's okay. That match the pattern, finds conjectures that match the pattern pat, or tries to find conjectures. Yeah,
But I thought form was the more important word. It's not about pattern matching. It's about, is it a angle, is it a line, or whatever?
Oh, really? But it says here that they're actual things like this. They're not named forms.
Right.
Well, are they named forms or are they explicit pattern matches?
Explicit pattern matches. We literally just find all conjectures that we can and do a cases.
This function is not well cooked, in my opinion. No, I mean, look, we should show what this does. Okay, so if I'm not mistaken, let me just see what this does here. If I give this, okay, I get this thing. Now I say, find geometric conjectures of this, right?
Yep.
Okay, so have we not agreed that this thing is going to show its conjectures?
Yes,
Right.
as a tab view.
Yeah,
Summary.
it's
Okay, so that'll be the first example here.
Yeah.
Okay, so what if I gave it something which hadn't been random instance? Would it also, what would it do then?
It would use random instance under the hood.
right. So under the hood, it runs 3 random instances and picks out the list of conjectures that's the longest. Since generally, if there's a degenerate scene, it'll return no conjectures.
Okay. This function is very weird. So are we going to end up with something that can do like these 2-column proof things that you find in geometry textbooks?
Right.
Yes.
Peter Burns is working on that, but it's not going to be ready until 12.1.
Okay. And is it consistent in its operation with this thing?
It will be.
Yeah.
Yes and no. I mean, what does it mean? What do you mean by this statement?
Well, I don't know. The form that it gives the conjectures in looks like the form that this is generating.
Yeah. It in terms of the language.
Yeah.
Yeah, that'll happen.
Okay.
I think what makes like originally a couple of months ago, we had a version where basically this returns the disembodied conjectures, but it's really not so useful. It's hard to make sense out of it. I think it's much nicer that it's one object and you have them all together. And maybe the name is not perfect because while it does find the conjectures, by the end of the day, it gives you a scene back. It would be something enrich scene with geometric conjectures, but it's probably not a typical.
Right. Well, so look. Okay, find geometric conjectures. Let's see. What we really want to say is something like attempts to include the geometric conjectures in the scene object.
Exactly.
To add. Finds geometric conjectures. Finds relevant geometric conjectures to add to the geometric scene object.
I mean, the first note says this basically.
I know. Finds applicable conjectures
Right, I held that.
to add to the geometric scene object seen.
No, this seems wrong because it doesn't find them to add. It finds them and adds them.
Okay, finds applicable conjectures and adds them.
How about adds applicable conjectures to the geometric scene?
That's the wrong thing to say because it's.
I don't like applicable.
Okay, well, what's the correct statement?
How about we go back to what we had and then at the very end of the sentence, comma, and adds them to the geometric scene. Finds conjectures that may hold for the.
What do you mean by may hold? That's not good enough. What do you mean by may hold?
Because it's
A
conjecture.
conjecture per definition may hold.
Well, conjectures, yeah.
What?
You can conjecture that 1 + 1 is 3. It's a conjecture.
Okay, but wait a second. Are the things that this is returning things that are guaranteed to be true given the geometric scene spec?
No.
No, yeah, they're
What do you
only
mean?
true
What?
for the particular instance. They're just numerical conjectures.
They are with astronomical probability correct, but not
Then
provable.
okay.
That's why it's find, because we might miss them, and conjecture because it's
Okay,
not.
find conjectures that appear to hold for the geometric scene object seen and adds the conjectures
What are we submitting there?
to the scene specification.
No, because we earlier used the word. Maybe. I thought we used scene specification to more or less refer to the second argument.
Okay. Add conjectures the scene object.
Scene object.
To hold for the scene object, for the geometric scene, and adds the conjectures to the scene object. Someone's asking, is this like find equational proof at all? No, this is not giving the proof. This is given a geometric scene, it is finding symbolic conjectures like that angle is 90 degrees about that scene. Well, okay, in what sense is it the same? I mean, I suppose it's the same as find equational proof in the sense that, and which should be referred to here, I agree, because find equational proof is finding lemmas that are true, but it is directed in a particular direction. Right? I mean, this is find equational proof has an objective of proving a particular thing. This is just saying, given the geometric form that I have, what might be true about it. And adds these conjectures to the scene object. Okay, so what does this do? Does this add all conjectures to all scene objects, or what does it do?
So if you're given a list of scenes, then it takes it runs the.
No, I understand, but what is the output?
It's a single geometric scene object, just like above.
Okay, finds conjectures that appear to hold for all instances scene I of a geometric scene, and returns a combined scene with the conjectures added. Appear to hold for. Okay, finds keeps only conjectures that match the pattern.
It keeps or adds?
Okay. This is pretty obscure. So, I mean, we should say this in the geometric scene documentation, right? Over here, we should show some examples where we have added some, probably the third, even basic example should add to this some thing where it has a conclusion, so you can see that that can hang off a geometric scene.
Oh,
We can do that.
okay, so this is actually.
They represent different instances. All right. I mean, this is a kind of obscure and complicated function, but it is what it is.
I think overall that's a much nicer thing than having this split into individual pieces, which you must remember, reuse to do something with. So it's a nice. It's a little bit like data set. You have everything in one nice object that does many things.
Yeah, I understand. I have a question on our live stream. Does this have engineering applications, or is it purely academic? We're first of all trying to just reproduce Euclid after a couple of thousand years.
Also,
But go ahead.
I'm saying geometry constraint solvers are used in
CAD systems
CAD
all over
stuff.
the place.
Yeah.
Yeah, right. And that's what this is. This is a sophisticated, you know, in this case right now, 2D geometric constraint solving system. Method of probabilism-based geometrics, and it's a method of storing and providing feedback. And ask for similar examples. I don't know about that. Okay. I think we should wrap this meeting. I think we've got what we need here. And I thank the folks on the live stream. And actually, I am about to go to another meeting about a completely different topic that will also be live streamed. So look forward to seeing you all there. And are we good here?
Yeah, we're talking to we are done with geometry. We can.
I think so.
Declare victory.
I think we can declare victory here. And victory it is. I mean, well, look, I'm going to be even more convinced when I can see. I think it'd be really cool to go through the geometric, you know, statements of Euclid and be able to put those up in this form. Is that plausible, or is that like super difficult, or what's the deal with that?
Well, as we saw, a lot of the Euclid is constructions, not really just a theorem.
Well, okay, fair enough. But I mean, take the things that are the theorems of Euclid rather than the constructions of Euclid, and can we represent them?
All right.
Yeah,
I think that will be, if it's easy to do, I think we should try to do it. I think it's a good way of explaining what we have. And then just generate a computational essay that basically is, you know, Euclid as a the theorems of Euclid as a computational essay, so to speak.
We can do that.
I'd really like to see it. Yeah. Okay.
Thank you.
Good stuff. See you later.
Wait.
Bye.